Alrighty, so in this problem they say f has critical values at 0 and 3, and the graph of f double prime is shown. We know that when f double prime is positive, f is concave up. When f double prime is negative, f is concave down. Which means, on this graph, wherever f double prime or the y values are positive, that means that f is concave up for this stretch of x values. And likewise, from 0 to 2, that means f is concave down, because f double prime is negative. So if they tell us that we have critical values at 0 and at 3, critical values are possible locations for maximums or minimums. So at x equals 0, we know that f is concave down because f double prime is negative. So if we have a possible location for a max at x equals 0, and we know that f is concave down, then that means we definitely have some sort of a max at x equals 0. Now, we'll talk about whether it's a local or absolute in just a moment. If we wanted to talk about x equals 3, f double prime is in the positives, which means that f is concave up, which means we likely have some sort of minimum, most likely a relative minimum at x equals 3. And so in these answer choices, they're just talking about x equals 0, so we know it's some sort of max at x equals 0. Now, if we imagine this graph here for a moment, we're going to have something like that. We'll try to spruce it up a little bit. So we have some sort of max at 0, and then it's concave down, and then right around x equals 2, it switches from concave down to concave up, right? So concave down to concave up, it hits that minimum at x equals 3, and then it could go up and be done right around, x equals 5. Like if we're just going from, say, 0 to 5 here, 5 could end right there. Like the function could end right here at 5, in which case this would be an absolute max. But we don't know that this function ends as low as that. Like this could just shoot up, and this could be a higher point at x equals 5 than this point, which would make this not an absolute max, but really just a relative max or a local max. So I'm going to go with a local max, because that's all we can say with certainty. It's some sort of local max. It's higher than the surrounding points. Even like I think that's how y'all do this definition. Like I would say right away, it's not a relative max. Let's just say relative max. I would say it's not a relative max because if there's not a function over there, like if there's not if the function doesn't keep going down on the other side, then we can't call it a relative max, but y'all might call it a relative max. Anyway, my best guess is it's a local max because we can't say the height of the function on the other side, something like that. All right, I hope this helps.